Assalamu alaikum. In the playlist of data structure and algorithm, we will discuss about some data structure techniques which will improve the time complexity of our code and many more efficient of our codes. So in the first video of data structure and algorithm, we will discuss about binary search. So why we will use binary search? If we look at some elements, here are 8 elements in the array, and if we look at the 15 element, so in the normal technique we will use a loop from 0th position to nth position, and if we find the target element we will print found. If the element we are searching for is example 50, so the element is not in the array, so we have to print not found, and we will close the loop and then print not found. So in the technique we have to use 0th position to n position loop. So the time complexity for the worst case is O of n, because when the element is not in the array we have to search from 0th position to the last position to searching the element if it is in the array or not. So here the time complexity becomes O of n. But when we have to find multiple elements in the array, the time complexity will increase. So if we look at this code, here we have some query and we have to run the loop for more than one time. So here in the worst case the time complexity will become O of n square. So this is not the efficient code to solve in 1 second or 2 seconds, whatever you will say. So in order to make our code more efficient, we will use binary search technique. So how binary search technique works? If we look in this slide, we will show the first condition of binary search technique is array must be sorted. Then in the second condition is we have to take two pointer, which the first pointer will start from 0th position and the last pointer will start from the last position. Then we have to find the mid element of the array. So here we will see the mid element. If we calculate, then we will find the mid element is 15. So we will compare our target element with the mid element. If the target element is equal to mid, then we will print just return the mid element. Then if the target element is greater than mid, then we will take the left, we will update our L position or left position, the left pointer to the mid plus 1th position. So the left will come here if the element we are searching for is greater than 15. If the element is less than mid, then we will update our right element. If the element we are searching for is less than 15, we can say that the element we are searching for is not greater than the mid element. So here we can eliminate this part of this array and just search for this part. So here comes the efficiency of our code. We can eliminate one part each time. Here we can say that the part can't contain the target element. So here is the pseudocode of binary search technique, and then we will see some example of how binary search works. So here we are trying to find 22 in the array. So here the array is sorted. Then we will take a left pointer and we will take a right pointer in the array. Then our task is to find the mid element. So the mid element is 15 here, and now our target element is 22. So we can say that 22 is not equal target. So we don't run this condition. The condition will not true. Then we will go to the next condition, which is target greater than meet. So here 22 is greater than 15. So we can say that the part which is less than 15 can be eliminated. So this part will eliminate, and we will update our left pointer to meet plus 1. So the left pointer will come here. Then we will repeat the process again. So here our meet position will update again. So for this L and R, the meet position will be 22. So 22 will be the meet position, and now the meet position is equal our targeted value. So we can return the meet. So here we see that we don't have to run the loop for 0 to n position. In case we can use left and right pointer, and then we are eliminating one part which is less than meet. Then we are searching again, and then we find our meet as the targeted value. So here the time complexity is less than the normal technique, and the code is more efficient. Then if we see the next example, the next example is we have to find 50 here. So if we find 50 here, the code is run for how many times? So if we take L and then we take R here, the meet is 15. Then we are checking meet equal is our meet is equal target. No, 50 is not equal 15. So we will update our left here. Then again, if we run we take the meet will be 22, and now our meet is not equal 50. Then we will update our left to where we will update our left or right. Now you have to make decision. So we will check 50 is greater than 22. Yes, 50 is greater than 22. We will update our left. So left will come here, and now we have to find our meet again. Now if you see, the meet will be 35, and now the left and meet is equal. Now 35 is not equal 50. The condition is not true, and 50 is greater than meet. So we have to update our left pointer again, and the left pointer will come here. Now the meet will be 40. So here left, right and meet is at same position. Now if we update, now we will see our condition again. Here the targeted value 50 is greater than 40. So we will update our left again one more time. So the left will come here. Now we will see that the right is less than left. So here comes the condition where we have to stop our binary search technique. So here we can say that if right is less than left position, we can surely say that our left is in the position where we can't find our element, and we can say that the element is not in the array anymore. So here how many times we have to run the technique? So firstly we are finding 15 meet as meet. Then here it is the first step. Then we find 22 as meet. Then we find 34 as meet. Then we find 40 as meet. So we run the loop for 4 times. Instead we will use the loop for 7 times in the normal technique. In the binary search, we use 4 times the loop, and we can say that our targeted value 50 is not in the array. So here is the efficiency of our code. We can say that it is just a normal array. If we take a bigger array, then we can say that the complexity of binary search will become log of n, which is less than n. And in the query, if we run binary search for multiple element, then the time complexity will be n log n, which is less than n square. So here is the technique of binary search, where the time complexity becomes n log n instead of n square. So in the next video, we will see how we implement binary search in the code.